Hello, my name is Cary Jensen, and welcome to CodeRage 9. This session is ClientDataSets and FDMemTables compared. I'm going to begin this presentation with a short review of in-memory datasets. I'll next discuss the ClientDataSet and FDMemTable components from a historical context, and then we'll look at the similarities and differences between ClientDatasets and FDMemTables. In-memory datasets are table structures stored entirely in memory. These tables can be hooked up to data-aware controls, or they can be navigated programmatically, but they are table structures just like tables that you would retrieve using a select query. The difference being that they're stored entirely in memory. In addition, in-memory datasets provide a number of important features that are not found necessarily in other datasets. One of these is cached updates and the support for change cache management. This allows you to make changes to multiple records without having that data written to an underlying database, and then to be able to either apply those changes, discard them, or edit them, such as undoing the last change that was applied to the dataset. In-memory datasets also support persistence to a file or stream. Importantly, when you persist a file to a file or stream, you're persisting the change cache as well, which means you can load that dataset again from file or stream, and that dataset will be indistinguishable from the one that existed prior to writing it to the file or stream. It will still have its change cache intact. You could then modify the change cache and then apply the results, or you could persist it to a file again and apply the updates to underlying database at some future time. In-memory datasets also support cloned cursors. Cloned cursors is a mechanism that allows you to have more than one current record in a dataset, which allows you to do very, very powerful things. In-memory datasets also support nested datasets. A nested dataset is a field that contains an entire table or dataset. Nested datasets themselves can have nested datasets, which allows you to support complex relational structures in a single in-memory dataset. Finally, in-memory datasets are essential for DataSnap client-server interaction, specifically the retrieval of data to a DataSnap client, allowing the DataSnap client to modify that data in a cached updates mode, and then resolve the change cache back to the server so that the data can be written to an underlying database. Client datasets were originally introduced in Delphi 3 as part of the Midas framework, which is now called DataSnap. The features of the client dataset were specifically designed to separate the data acquisition from the data storage, specifically the client dataset and the dataset provider interaction. And this that is the source of the client dataset. FDMemTable was designed as a general in-memory table for use with FireDAC datasets. So with the introduction of FireDAC in Delphi XE3, we also obtained this new in-memory table. Now, the FDMemTable is actually used by other FireDAC datasets, such as an FD query. The FD query uses an FDMemTable as well as an FD data adapter and an FD command to perform its operations, and that's why the FireDAC datasets support cached updates, data persistence, and a change cache. As recently as XE5 Update 2, a new runtime library unit was added that supports FireDAC memtables in a DataSnap implementation, and I'll demonstrate that a little later in this talk. Finally, client datasets and FDMemTables are both T-dataset descendants, which means they can be used anywhere a T-dataset is employed, which means all the data awareness in both the VCL and FireMonkey component libraries. For the remainder of this talk, I'm going to focus on the similarities and differences between client datasets and FDMemTables. I'm going to begin with a discussion of design time differences, but we'll also look at the persistent formats, how queries are configured with these in-memory tables, cached updates, master detail resolution, the DataSnap support, and then some other miscellaneous differences that we'll find. Let's begin with our design time differences. We'll look at creating a structured design time, loading data from a dataset, loading data from a file, saving data, differences between persistent and temporary indexes, and expression engine functions that differ between the two different classes. Okay, let's go over to Delphi and see how this is done. We'll start by creating the dataset structure at design time. Both ClientDataSets and FDMemTable structures are defined either by using field defs or by using the fields editor to create T fields. I'll demonstrate the ClientDataSet structure creation using a field def. So in this case, I'm only going to create one field. I'll call it first name. This is going to be a string field, and we'll make it 30 characters in size. For the FDMemTable, I'll use the fields editor. And in this case, I'll create a new data field, and we'll also call this first name, and make it a string and 30 characters in size. Now the steps for creating the structure is slightly different in that you define the client dataset by right-clicking and selecting Create Dataset from its component menu, and you'll notice the structure showing up there. Within FDMemTable, it's just a matter of setting the active property to true, and that created the structure as well. Now we have an active table. We could do things like save the structure to disk if we wanted to. What I want to talk about next is the clearing of the dataset. With the client dataset, you simply right-click and select Clear Data. Now you do the same thing with an FDMemTable, but you got a little bit more to do because the FDMemTable is very sensitive to its field defs and its T fields, and so clearing that data did not clear the created T field from the fields editor, which left the, let's see, why is that? Well, it actually worked. What happened is it set the active property to false. I should have set the active property false before deleting that field. Now, if we also had field defs defined here, we'd want to go over to the field def editor and delete any of those as well. Again, it's only necessary because the FDMemTable is sensitive to that structure. So if we try to put another table, we try to load a different table into the FDMemTable, it would complain because of the leftover T fields. ClientDataSet doesn't have that problem. So now let's look at loading the dataset at design time. With ClientDataSet, you right-click and select Assign Local Data, and then you can select from any T-dataset descendant that you want. Now, I have an FD query over on a data module, and it is active. That's very important for the FDMemTable here. I selected that for the ClientDataSet, and I loaded up the dataset. Now, if I come over to the FDMemTable and I select Assign Dataset, it's very similar to what we saw with the ClientDataSet, except for the fact that we can only load from FireDAC tables. If we tried to load from that ClientDataSet, for instance, we would get an exception. Okay, that's how we load that data. So now what I'm going to do is show you how to load from a file. With the ClientDataSet, you select the ClientDataSet and you go to the file name property, and you then search for your file and load it. And I'm going to pick up one of the sample files that ship with RAD Studio. Come to Samples, Data, and I'll select the customer XML file. And now if I set to active, the ClientDataSet will load that file. With the FDMemTable, it's similar, but you will not see a file name property that is published. Instead, you go to Resource Options. So Resource Options, and under there you'll find a persistent file name property, and there we can select the files as well. So in this case, I'll select one of the FireDAC binary files and open that, and then we'll set active to true to load that data. Now we have the data. Now, saving the file at design time, you may have either you may have loaded a data and you want to save it as a different format, or you may have created a structure and you want to save that structure even though it's empty, but use that structure then from your application at runtime. With a ClientDataSet, you right-click and you select one of the save options to save the file. And notice we also have a load, which would allow us to load the data also and that would load the data directly without assigning the file name property. So in this case, I can say that I want to save to a binary file that typically uses the CDS extension, and we'll just say this is customer new, and save. Oh, I misspelled that, but that's okay. Very similar thing with the FDMemTable, we select Save to File, and then we select the type of file that we want to save, and then we can provide a name and save that file. Okay, persistent indexes. I'm not going to go through this other than to say that the primary difference between persistent indexes at design time, and this is true about runtime, I should point out as well, is that client datasets don't support expression indexes, but FDMemTables do support expression indexes. So that's an option you have. Temporary indexes are indexes that are defined using the index field names property, and that's a property that you assign a semicolon separated list of field names, and it will then dynamically create that index on the fly. In ClientDataSet, all of the fields will be sorted in ascending order, and it'll be an case insensitive sort. The difference with FDMemTables is that we have the option to have a mixture of ascending and descending indexes. And the way we do that is we follow the field name. So I'm going to put in the company field name. You follow it with a colon, and then for a descending index, you put a D. Now, if I had more fields, then I'd put a semicolon, I'd put the next field name, but that really isn't really necessary here. So once I select that, we just got our sort. Now, if we want an ascending index, we can specify A, but that's for ascending. But that's really not necessary because ascending is the default. This is not required. If we just put the field name there without any colon and a sort direction, it's going to sort in ascending. The final difference is in the expression engine that you can use in your filters, constraints, and other places. Delphi's ClientDataSet has an expression engine, and it has a number of special expressions that you can use in filters. There are datetime functions and character functions and so forth. FireDAC also has an expression engine, and it's much more extensive. It's used primarily by the SQL preprocessor, in which you can place certain escape sequences and various function calls, and those will be processed in your SQL before the SQL is executed against your underlying database. But these can also appear in your filters, and I've done that here. What I have here is a filter that will look only at the year portion of the last invoice date timestamp field, and then we'll filter only on those records where the date is prior to 1990. So if I go ahead and click here, my filter is now in place. I'll scooch over here, and we'll come and look and see that we only have filters in the correct, or we filtered our records for the correct range. Next, we're going to look at query configuration. Basically, the ClientDatasets and FDMemTables are capable of having influence on the queries that are going to be executed to load them, and this can be done at runtime. And the ClientDataSet supports design time configuration as well. The ClientDatasets interact with the dataset provider to make adjustments to the query, and the FireDAC FDMemTables interact with an FD table adapter and an FD command. And like I said, ClientDataSet can do this at design time. What I'm going to do is, let's go over to Delphi, and I have a project that is going to demonstrate how to do this at runtime. So query configuration. I have the ability to select between a ClientDataSet and an FDMemTable. This is a very similar project to the last one in that I do have a data module in my project, and the data module has a FD query and an FD connection. Now these are all configured at runtime. Essentially, I'm using from Delphi, I'm using the demo's dir environment variable, and I'm using that to point to where the demo data is stored. And this configuration occurs when the data modules are created in this project. If you want to activate this query at design time, you're going to need to make sure that that your FD connection is pointing to the right location for your data. In this case, I'm pointing to the location that is being used by RAD Studio XE7, which is different from XE6 and XE5. So that's why I'm using that environment variable. Okay, let's go ahead and run this. And when I execute my ClientDataSet, I'm getting all the records where the salary is above 0 if I change this to something like 40,000 and execute it again, I'm going to get fewer records. That's using the client data set. The same thing is being done with an FDMemTable. So I go over here, that is that query. Let's go ahead and change this value to 30,000 and re-execute the query. Now we're looking at the FDMemTables execution of the query. Let's now go and look at see how this actually was performed. So with the client data set, I have made sure that the PO allow command text flag is in the dataset provider's options, and then I'm assigning to the command text property of the client dataset a SQL statement. Now, client datasets don't have a SQL engine, but what they will do is pass the select statement to the dataset provider. The dataset provider will apply that SQL statement to the dataset to which it points. This happens to be a parameterized query, so I'm using the params property of the client dataset to assign the value from the edit, and then I'm opening the client dataset. And then whether I'm using the cached updates or not is controlled by a checkbox that's on that main form. Now, it's a very, very similar thing we're doing with the FDMemTable. The difference is instead of just using a dataset provider, which points to a dataset, we're using an FD table adapter, which can hold a variety of different commands. And those commands are actually FD command instances. So, but going back over to the code, we see something that's very similar. I'm setting the select command of the table adapter to the FD table adapter to the FD command. I'm setting the command text property of the FDMemTable, which, by the way, is a public property, not a published property. I'm assigning the same select statement, and then I'm using param by name to assign the value from the edit, and then I'm opening the FDMemTable. So very, very similar operations between these two. What is important about both of these is that in the case of the dataset provider for client datasets, if I make changes to the client dataset and then call apply updates, the dataset provider will use SQL resolvers to create these SQL statements that will apply the changes to the underlying database. With the FDMemTable, it is the FD table adapter that will generate all necessary update, insert, and delete statements based on the select statement. Now you can actually customize those statements if you want, but it will generate statements on its own as well. And that brings up another thing that I think I mentioned later in my slides, but in FDMemTable, its cache defaults property is false when it's first created, which is different from a client dataset, which starts its life always with log changes equal to true, or in a cached update mode. What's interesting about the FDMemTable is if I'm not in cached updates and I post records to the FDMemTable and it's pointing to an appropriate table adapter and FD command, it's generating record by record updates at the time of post. So I post a change to the FDMemTable, immediately the table adapter and FD command have worked together to write the data to the underlying database. Okay. Let's now talk about cached updates difference. Now, I'm not going to use a code example for this because there's actually, cached updates is a very, very big topic. I just mentioned that client datasets default to caching updates. So the default value of log changes is true on a client dataset. In an FDMemTable, the cached updates property is false by default. Now, another big change, this is something you need to be aware of when you're designing your applications, is while the client dataset defaults to an update mode of up where all, and by the way, that update mode is actually a property of the dataset provider, the FDMemTable defaults to update where key only. And there's a critical difference between these two settings. Update where all uses the key fields of the underlying data table, as well as all non-blob fields in the where predicates of your update statements. So basically what that assures is that if the record has changed since you read it into the client dataset, update where all will fail. By comparison, up where key only, that mode will only look for a record with the same primary key values and then replace all the values on it. This is the last user to post a change will actually replace posts that were made by users who who applied their change since you loaded this data into the FDMemTable. It's done for performance purposes, but it is really a critical difference in how updates are applied by default. You need to be aware of that. Most developers prefer the up where all. There's also an up where changed, which allows multiple users to merge their changes together. But that's, I'm getting a little bit off track here, but that's an important change to understand. Client datasets also can apply their updates to nested datasets. And while there's the ability to have one-to-many relationships with FireDAC memtables, it is not that cached update operation is employs something called a FD schema adapter, and it does not use nested datasets for that purpose. I'll come back to nested datasets in another slide, but that is a major difference in cached updates. And then overall, the properties and methods of FDMemTable and the client dataset where cached updates are concerned are different. And if you want to get into those differences, what I recommend is you take a look at my CodeRage 8 talk on FDMemTables. Actually, it's FireDAC, cached updates in FireDAC. And then on CodeRage 5, I had a cached updates talk about client datasets. And there, especially in the CodeRage 8 talk, I talk about the differences between the FireDAC cached updates. And there are subtle differences. Some of the properties don't work exactly the same. Calling apply updates is a little more involved with FireDAC. But I'll leave it up to you to check out those presentations and look at those differences. Now, as far as master detail relationships, a client dataset is capable of loading nested datasets when its dataset provider is pointing to the master table of a dynamic master detail relationship. Then, when you do that, the client dataset itself is going to obtain nested datasets to hold the detail records. You can get very fancy about this. You could have a master table that has a detail table, and then a detail table that's dynamically linked to a sub-detail, and then a sub-sub-detail. And what will happen is the client dataset will have a nested dataset field, and within that nested dataset field, there will be a nested dataset field, which itself will also contain a nested dataset field to get those 4 layers of relationship. With an FDMemTable, they support dynamic master detail links, but if you load an FDMemTable from the master table of a master detail relationship, you are not going to get the nested datasets. And I'll demonstrate this in this example here, master detail. Okay, this project also has that same data module. So I have my connectivity to interface here. Here I have a FireDAC query that is the master table of a master detail relationship. This orders query is using the master source and master fields properties in order to link and produce a master detail relationship. If I take data source 1 and point it to customer query, let's see, customer query, and then take this one and point it to the orders query, and then activate everything. Specifically, I come in and activate this table and this table. You'll see that there is a master detail relationship. And then if I editor for this query, I can navigate, and you'll see that as I navigate the records of that master table, I'm getting updates to the detail. So if my client data set, and it has a dataset provider, and it points to customer query, and I open this client dataset, something very, very interesting happens. Specifically, I get a nested dataset field for the orders table. So customer client dataset, and we'll see that over here. We scroll over, and there's my nested dataset field. Now, with a client dataset, what you typically do is you use the fields editor to add all the fields, and there's our dataset field. You take a second client dataset and you point it to that dataset field, and what that does is it allows you to then have a design time orders. Let's see, where is that orders client data set? So now we're looking at the nested data set contents of that data set. So we're looking at the client data set, and here's the nested data set field, and I can even double click on this and get in there and see that nested data set field there and here. But this is, you don't have control over how that looks. So that's why we use the client datasets dataset field to hook up a second client dataset for the purpose of showing the nested dataset field. Now we can do something very, very similar with the FDMemTable. So I've got my customer query and my orders query, their master detail, and I can take my FDMemTable and actually point it over to that customer query. And now let's go look at it and set to the customer FDMemTable. So, but if we look over here, we don't find a nested dataset field. So that's another difference between client datasets and FDMemTables. Now, to be honest with you, the FDMemTable, it uses a different mechanism for cached updates when you have a master detail relationship. And as I mentioned just previously, there is a class called FD schema adapter, and when you have two or more FDMemTables or any type of FireDAC dataset using the same schema adapter, you can when you enter a cached updates mode, the schema adapter is managing the change cache for all of those FireDAC datasets. That's a different approach entirely compared to the client datasets, which uses the nested dataset specifically for the purpose of managing cache for master detail relationships. Let's now turn our attention to DataSnap. DataSnap support for FireDAC FDMemTables is relatively new. However, with client dataset has been part of the framework since the beginning, back in Midas in Delphi 3. In short, DataSnap operates by transferring data from a server to a client, where the client will hold the data in cache, maintain a cache change log, and then send that change log back to the server, where the data can be resolved to the underlying database. This is a strategy that allows for thin clients, that is, clients that don't really touch a database directly. They get their data and resolve their data through the services provided for by the DataSnap server. Client datasets communicate with dataset providers that reside on the server, and that makes things work very, very well. FDMemTables don't have that same kind of companion component that could reside on the DataSnap server, so things are quite a bit different. Instead of using the simple exposure of a dataset provider from a DataSnap server, you actually have to create custom methods on your DataSnap server and call them from your client application. Fortunately, beginning with RAD Studio XE5 Update 2, a new unit called FireDAC JSON Reflect was introduced, which works to package up FireDAC datasets and transfer them to the client, populate FireDAC FDMemTables in the client with that data, which will then maintain a change log, and then package up the deltas from the FireDAC memtables being used on the client to send back to the server, and the server can take those deltas and resolve the data back to the underlying database. The one thing that's missing on the FireDAC side is because of the client dataset's use of command text and params, the client dataset can greatly influence the queries that are executed on the server from the client. In order to achieve that using FireDAC FDMemTables, you would have to actually create custom methods on your DataSnap server, which would accept SQL statements and params and so forth from the client application. This is a really huge topic, and there's no way for me to really do it do it properly, but I'll try my best to go through this. Here is my server methods unit in my DataSnap server. The most important thing about this is, well, there's two aspects. One is that it's a DS server module, and the second is that it has a dataset provider on it. The DS server module is able to expose that dataset provider to potential DataSnap clients. Now, in this case, the dataset provider is pointing to a query. However, as I described, well, and this query does have a query already in it, but the That's just a detail. The client dataset could actually, through its command text property, set that query from the client. The most important thing about this is that there's really no interface to this DataSnap data module, except for that which was generated by the DataSnap server wizard in the object repository. I haven't had to do anything custom. All I've done is set up a dataset provider. I could have multiple dataset providers, and they are accessible from the DataSnap client. The DataSnap client is using a client dataset, which, hooking up through a DS provider connection and a SQL connection, is able to see the dataset providers and then execute them. So if we just take this DataSnap server and run it, it's going to be live. And now, even from we don't even have to run our client application. We can just come in here and hit active, and it's pulling that data from the DataSnap server. If we were to do this at runtime and we're maintaining a cache, we can call apply updates on the client dataset, and it just seamlessly is going to produce a delta that it returns back to the DataSnap server, and the DataSnap server, using the dataset provider, will apply those changes. Now, this is it's very, very different on when we are using FireDAC, and I won't go into a lot of details. I'll just really give you the highlights here. First of all, I've got a query here, and using the FireDAC JSON Reflect, I get a series of classes that I can use. One of these classes, FDJSON datasets, is used to package up one or more FireDAC datasets into a package. And that is what's returned by this custom method that I added called getCustomerData. In the implementation of getCustomerData, I'm opening the query, fetching all the records, and creating this FDJSON datasets object that I'm then writing the dataset to. If I had multiple datasets, I'd have multiple calls to list add. Then I'm also exposing a method that receives a FDJSON deltas object in return, and what that method does is it extracts the deltas, it creates this FDJSON deltas apply updates, and uses that to apply updates to the various deltas that are returned back to the server. So from the client application, we have a very similar situation. We have a SQL connection, the FD, and then what we did with the SQL connection is we selected this generate DataSnap client classes, and that produced this, that produced the server methods client class, which was generated, and it has now serves as a proxy for the methods that we exposed on the DataSnap server. So it's through this object here, this class, that we are going to call getCustomerData and then resolve the data by calling apply customer updates. It's a very different approach, and we could, of course, create any interface we want, any API for our DataSnap server, but we're doing things manually by setting this up. However, this is how we get we can use our FDMemTable, the power of the FDMemTable, in a DataSnap environment. Okay, other differences between client datasets and FDMemTables. Well, first of all, FDMemTables can actually automatically write their data to an underlying database on a record-by-record basis. You cannot do that with a client dataset. So the FDMemTable would point to a table adapter. The FD adapter will point to an FD command that has a select statement. The memtable will then load the data through the table adapter, and as you make changes, as long as you're not in cached updates mode, the FD table adapter will generate the necessary insert, update, and delete statements based on the record-by-record operations you're performing on the FDMemTable. Client datasets have another burden, and that is Midas.dll. Midas.dll is the heart and soul of the client dataset. Fortunately, you don't always have to deploy that DLL. Instead, if you just use the Midas lib unit in your project uses clause, you can avoid shipping Midas.dll, and that's a big advantage. Now, here's another difference. With FDMemTable, the cached updates property cannot be set to false if there's records in cache. With a client dataset, if it's caching and you set its log changes method to, or a property to false, you just lose your changes. With an FDMemTable, you actually have to either flush the cache by committing it or canceling it before you can exit the cached updates mode. Or the other alternative is just simply close the FDMemTable and it will flush the cache itself and you'll lose your changes. Client datasets do have issues with when they get a lot of records in them. It's something I've seen over and over again. Or somewhere around a couple 100,000 records, you get a problem. FDMemTables don't have that. And generally, FDMemTables are faster than client datasets. And here's one point I want to kind of emphasize is that I expect that as we go forward with RAD Studio's development, you're going to see a lot of emphasis on FDMemTables as the go-to in-memory dataset. I don't think we're going to see any more changes to the client dataset class. Okay, general conclusions. Client datasets and FDMemTables are different in a number of important ways. And if you're real familiar with client dataset, don't make assumptions about how FDMemTables work. Test it. Make sure that you are comfortable with the way FDMemTable approaches its solutions. And FDMemTables cannot completely replace client datasets, at least not yet. Client datasets can interact with NET datasets, such as an ADO dataset or a SQL connection and a SQL dataset. But the FDMemTables are specific to FireDAC datasets. Now, here's another important point, which is when you're using FireDAC as your data access mechanism, your need for FDMemTable is actually much lower than when you're using some other data access mechanism, simply because FireDAC's datasets, such as FDQuery, do many of the things that you might have previously used as an argument for using in-memory datasets. For instance, an FDQuery can cache updates. It can persist its data to file or stream. It supports aggregates. It supports group state and other similar features, largely because it encapsulates an FDMemTable. So your need for FDMemTable is actually lower when you're using FireDAC than when you're using other data access mechanisms. However, FDMemTables are the in-memory dataset of the future. If you do have a choice between a client dataset and an FDMemTable, go with the FDMemTable. Thank you for attending my session today. You can find the code samples associated with this presentation at jensendatasystems.com/CodeRage9. I also want to draw your attention to Delphi Developer Days, the annual training tour that I do with my fellow presenter, Dr. Bob Swart. Also, I want to let you know that I'm coming out with a new edition of my Delphi In-Depth Client Datasets book. This book should be available in mid-November. I also invite you to consider meeting me at one of the following conferences: EuroDevCon and Entwickler Conference, number 18 in Cologne, Germany, November 3rd through 5th, and the Software Development Network's annual SDC Software Development Conference in Arnhem, the Netherlands, on December 1st and 2nd. Also, if you need to contact me with questions or follow-ups, you can contact me at cjensen@jensendatasystems.com. You can come to my website at www.jensendatasystems.com, and I ask that you consider following my blog at caryjensen.blogspot.com and following me on Twitter at twitter.com/Cary Jensen. Once again, thank you very much.
So now you're in Germany already, right, for the conference?
Yes, I'm sitting on the 5th floor of your nice hotel in West Cologne, Germany. It's a beautiful day, though I must admit I haven't been outside yet. I just flew in yesterday. Anderson's here with me as well. So not really jet lagged, but taking it easy and enjoying CodeRage.
So there's a lot of questions here. You've actually been answering a lot of them as we went along. Can one in-memory object contain updates to several tables in one, or do I need to update one table at a time?
In both ClientDataSet and FireDAC FDMemTable, you can have multiple updates across multiple tables supported. The technology for using that, or the components used that, are quite a bit different. With ClientDataSets, you use nested data sets. When you're using FireDAC FDMemTable, you have multiple FireDAC FDMemTables associated with a single FD schema adapter. The schema adapter itself is maintaining the change cache. Now, that's how it would work in a traditional client application. It's a little more involved in DataSnap applications because you aren't going to have you're not going to have multiple FDMemTables associated. Well, I should say there's no framework yet for passing the change cache or scheme adapter from a DataSnap client to a DataSnap server. So what I do is I package up multiple FireDAC deltas and pass that back to the server, and the server will apply each of the FireDAC FDMemTables under a transaction. But I will point out that really looking for this multiple table managed cache applied under a single transaction, you're probably, if you're using FireDAC as your data access mechanism, you're probably not going to actually use the FireDAC FDMemTable. You'll use FireDAC queries or FireDAC stored props. Internally, they use FireDAC FDMemTables. So in many respects, it's kind of easier to do multiple table updates with FireDAC FDMemTable. You just use the FireDAC queries, multiple FireDAC queries plugged into a single FD schema.
Here's a question on your new book, wanting to know if it contains information on FDMemTable or is it just on the client dataset?
It is exclusively ClientDataSet. I anticipate that this will be the last edition of that particular book because, as I mentioned on the slide, we should expect an increasing reliance on FDMemTable in RAD Studio technologies going forward. What that book does, though, is bring everything up to the current XE7 release of ClientDataSet, and also published a whole new set of examples, code examples. I still maintain the original code examples that use the Borland database engine and paradox tables, but the new code examples use FireDAC as the data access mechanism and Airbase as the database. There's also updates throughout to enhance the content. It's a very similar book, though. There was a lot in the book that I was extremely happy about. So I added quite a bit here and there, but for the most part, the book is very, very similar. And I did, in fact, in the newest version, I removed the DataSnap chapters, 3 chapters on DataSnap. I removed them because that really needs to be rewritten entirely for the new DataSnap and DataSnap with FireDAC FDMemTable. So I consider that.
So another question is if you're planning on writing a book on FDMemTable maybe after you finish this one.
That would be nice. I have a number of books that I've got in mind. I have to really pick and choose. I just finished the final draft ClientDataSet second edition, so I'm going to be. I have to think about it. I've got some other projects on my plate as well. So I definitely believe that sometime in the future there will be an FDMemTable version. And it's not actually to say an FDMemTable version. That's not really fair. It would be a book.
Are there any plans to have your new book, your new edition, released as an ebook as well as a print book?
Yes, we're going to have a Kindle version.
It'll be Kindle, is that what you said?
Should see that. Yeah, it'll be Kindle, but then again, on the Android device, so you can download the Kindle reader for tablet or phone. So if you were reading a book on the phone on the train, you will be able to see.
So Walter says he has a very large application using DataSnap and client datasets in a multi-tier structure. Is it viable to change the structure to use FDMemTable?
Okay, so this answer is it viable to change the structure to use FDMemTable? It is, but I wouldn't do it right yet. I anticipate, I demonstrated a little bit about FireDAC JSON Reflect. That is what I believe to be an early go at involving FDMemTables in DataSnap and RESTful applications in a DataSnap environment. I anticipate that we're going to see that approach expanded as we go forward in the future. There's a lot you can do with client datasets, especially if you're just working with the traditional DataSnap client server and not relying on REST. There's a lot more that you can do than what easily you can do with client datasets right now in the DataSnap architecture. that will change, I believe, over time, because the FireDAC FDMemTable has a lot of very, very powerful capabilities, but it's going to require more infrastructure in DataSnap to make that readily accessible. So I wouldn't go and change my application just yet, but I would keep my eye out for what's coming out of Embarcadero.
Richard says, I think you said you currently can't move data from a client data set into an FDMemTable. Is that correct?
In terms of, you can't take a client data set, XML data property, and just assign it to FDMemTable. You can't take the XML saved file created by a client data set and move it into FDMemTable. What you'd have to do is some other mechanism where you read the records from the client data set and pump them into the FDMemTables. Currently, you could use, I believe, the FireDAC fashion might be useful for that purpose, but the internal structures of these in-memory data sets are not compatible. So there's not just a take this chunk and move it over of data from one to the other. So that's correct. You're not compatible at that level. But read record by record, you in fact could do it easily, but I'm not sure why you would necessarily do that. More likely, it's where did the client data set data come from? If it came from a file, then you do a one-time move into a client data set, pump the data into an FDMemTable, and then save it. If they're coming from an underlying database, just throw away the client data set and point the FDMemTable to that table or query result through the FD table adapter and an FD command.
How is it working refreshing data on client side when using FDMemTable? You show getting all data set and applying updates, but what with refreshing? I need to get all data set. Do I need to get all the data set again?
I believe on both client data set and FDMemTable can refresh the current record. I really don't know. I don't have a definitive answer for that question. I would be speculating. But in terms of loading and refreshing, there are a lot of similarities between client data set and FDMemTable.
Okay, so you should be able to refresh the current record, but you're not sure, but there's a lot of similarities between the two. All right, well, I think that is it for the questions. Okay, Richard says, really like the first edition and refer to it a lot, so looking forward to buying a print and electronic copies of the second edition. The Delphi Developer Days, I've been to, I think 3 years now I've been to Delphi Developer Days, and I get a lot out of it as well. It's a good conference, lots of good information, and you get that nice, big, huge book of courseware that you guys put together, so.
Well, thank you for saying that, Jim. I appreciate it. We work hard on that book, too. It takes a lot of time to create it.
Yeah, I'm sure. There's a lot of stuff in there.
And I'm very, very sorry that we don't have good audio. I wish it was much better. Unfortunately, there's not even a McDonald's that I can go to try to use their
So, yeah, great information. Thank you so much, Cary. It looks like we've got 5 minutes and then nested data sets in client data sets. So everybody stay tuned for another dose of Cary Jensen on data sets.
Excellent. See you soon.
See you soon.